want to thank you for taking a little bit of time to join us today. And we are going to do our best to give you some tips and just nothing else, bring some things back to light when it comes to testing our batteries. So a few things that we do want to talk about. Battery 101. What is a battery? How does it work? What's the functions of it? We do want to look at proper procedures. So we're going to introduce some of these and how we do it, as well as why are they important. We know that we can just throw batteries on, we can do all that, but if we test them, we're going to fix the problem instead of just doing part swap. So that's what we're trying to do today. All right, so first thing we need to know is what are volts? Because volts is a big thing that anytime we're looking at batteries, we say, you know, what's the voltage on it? So a volt actually is the pressure in our electrical circuit that is pushing the electrons through. Basically, it comes down to it is the pressure difference between 2 points in the circuit, and we are measuring it in volts. Most of us use a multimeter, so we make sure that we're on the DC or the straight line voltage scale when we do. Now, amps happens to be the current flow. So what this means is how much can I get through? And when it comes to a starting circuit, I need a lot. When it comes to the rest of the circuits on the truck, I may not need as many amps going through there as I do. But at the same time, the more resistance I have, the more I choke it down, and I can't get enough water through that pipe or enough electrons through that pipe for that system to work correctly. So we need to know about that. Now, the one thing about a complete circuit is whenever I have current flowing, I'm going to see that same amperage not only on the positive side, but on the negative side of the circuit. That's what we're showing you here. The red line indicates the positive, the black indicates the negative. The same goes true whenever I'm checking for draw in a circuit or a load. So I need to know how much current is flowing, so I'm actually using the right tool as well. So let's build this battery. So in the battery, I've got both positive and negative plates, and it takes many of those to make up a cell. We have a liquid electrolyte of some type, and it may not be necessarily be liquid, but we have an electrolyte in there. And the specific gravity, now I can't always measure that specific gravity, but that is the weight of the electrolyte compared to water. And that gives us a good indication of the chemical makeup of that electrolyte. So we know if that thing's working, if it's fully charged or not. It tells us that it's that piece of it. So when I put a load on, I complete the circuit. What's happening is I've got a chemical change in there where my sulfuric acid and my lead in my plates are interacting with each other to create that charge or that movement of the electrons. As that acid is absorbed by those lead plates, that's how I discharge my battery more. So that's the one thing we always want to make sure of, is we know that chemical change going on. It will get to the point where I have no load there. I have no current. I can't flow any current because I have no pressure. So what we see there is the sulfating process. And what that is that lead paste on those batteries gets where it starts to dry out. And in our recharge process, we want to absorb that as much as we can. So, jump too many slides ahead. Hold on. So when I charge it, I'm driving the acid out of that paste, that lead paste that's on the plates itself, and bringing that back, and I should be bringing my electrolyte level or my specific gravity in there back close to the fully charged position, which is that 1.270 that we saw earlier. Usually to get it completely recharged, it's going to take a slow charge. You can do a quick charge, bring it back up, but a slow charge over a long period of time is actually going to get most of that sulfate out of there. So fully charged battery on a lead acid battery, and this is what we call a flooded cell is another name for it, uh, is 12.6 volts. When I do an absorbed glass mat, and that is where my electrolyte has been absorbed into a fiberglass or some type of a mat inside of it, I then see that at 12.8 volts. Based off that percentage, I can see at what point is my state of charge. So, few things we got to know about the battery. What uh, what readings are important to us? And one that we always refer to is cold cranking amps. Now, the cold cranking amps is how many amps that battery is going to produce at 0 volts for 30 seconds. And I've got to maintain that voltage of 1.2 volts per cell. So I can't go up, that battery cannot go below 7.2 volts. So cold cranking amps, big importance, especially when we're talking about a starting battery for that vehicle. When I look at reserve capacity, so this is, I'm going to allow the battery capabilities to sustain a discharge. And I'm going to, it's going to be defined as the number of minutes where a fully charged battery at 80 degrees, so this is going to be on a flooded cell, 12.6 volts, I can discharge that battery at 25 amps and maintain 1.75 volts per cell. Get it out here in a minute. So I'm going to do at least 10.5 volts. Now, when I'm looking at the application, that's going to depend, am I more concerned with the CCA or the cold cranking amps, or do I go more for reserve capacity? It's always my choice here. So if I'm looking at, say, liftgate batteries, I'm going to look more for reserve capacity than cold cranking amps, because we know that liftgate's going to draw that voltage or that amperage down. It's going to be a continued draw on that circuit. So I need to know I can run it longer. Where when I'm starting a truck, I especially need more CCA or cold cranking amps. So when I'm in a colder climate, my batteries can handle that load that's going to be applied there. So we look at amp hours. And why do we look at amp hours? Because that tells us a little more about what kind of reserve capacity I'm going to need as well. So if I look at 1 amp hour, I'm running 1 amp, 60 minutes, 1 amp hour. 10 amps, an hour, 10 amp hours. And it goes on. So if I'm doing 1 amp for 10, I'm still 10 amps, 10 amps for 10 hours, 100 amp hours. So here's our first poll question. What value is more important to the quality of the battery? Is it CCA, CA, reserve capacity, or depends on the application? We're going to give you a minute or two to answer that question right now before we get into it. Got some of you guys on there. Now we're getting there. Looking at a few. Should be getting our results here shortly. Still have time. All right. Let's look and see what these results are. So some of you guys are paying attention here because 17% said CCA, 11 said reserve capacity. The right answer here depends on the application. The one that we really don't look at as much as cranking amps, because that is measured at 30 to 32 degrees instead of at 0. We want to know that we can start that vehicle, do it in a colder climate. So that's why we focus on CCA and reserve capacity. So here's another question. What's going to discharge a battery more? Is it going to be starting the engine 10 times? Is it going to leave the refrigerator on over the weekend? So about 3 days there. Or is it going to be lights that are left on during a delivery? What do you think on these? Once again, we're going to give you a little bit of time here. All right, let's see what our answers are here. So we're looking at starting at engine 10 times, refrigerator left on for the weekend, or lights left on during delivery. And believe it or not, even though we think an engine is going to drain it more, it's the refrigerator left on over the weekend that will drain our batteries more. Let me show you a little bit why we say that. Because if I'm looking at, and guys, I had to do all this math myself, so this isn't something I normally do. If I start an engine 10 times, say that's 15 seconds, roughly 1200 amps. And usually I see that as a peak and then it drops down some, but we're just using that 1200 amps. So if I'm doing the math, I've got 5 amp hours times 10 starts, and that equals your 5 amp hours. Now, how we came up with that 5 amp hours is we took the, here it is, 15 seconds. So I have to figure out in there, I've got to figure out how long is that 15 seconds out of 60 minutes, because that's my hour. And that comes down to 0.25. So it's a quarter of a minute. I've got take that quarter of a minute times 1200, divide that by, which equals 300, divide it by 60 is where I get my 5 amp hours. So kind of figured that out that way. So I've got the 5 amp hours. I've got a refrigerator left on over the weekend. We know 3-day weekend, that's 72 hours. That refrigerator's drawing 4 amps. Well, that's an easy figure. It's 288 amp hours. We're just going to multiply the hours times the amount of current we're drawing. Lights left on during a delivery. So it's a little long delivery here. We got 2 hours. It's going to draw 40 amps. So in that case, I'm only 8 amp hours. So the difference there is between the 72 hours versus the 2. And that's why that refrigerator actually can be left on, or being left on over a weekend is not necessarily the best thing for your electrical system and your batteries. And this gives us a little more indication when you compare your batteries, what the level of discharge is. That's why we talk about this. So if I'm trying to do a starting, I'm only hitting about 85% of that rate of the battery, so it's an easy recharge. It's going to absorb and bounce right back. The same with leaving my lights on for 2 hours. Now I've got 80% capacity. Excuse me, it's a little yet when I'm running that refrigerator, I'm down to just over 25%. So if I look at that voltage wise, just on a flooded cell, that 90%, I'm looking somewhere in the 12.4 to 12.5 range with what I'm discharging it to with the starter. When I get to my lights, I'm definitely down to the 12.4. When I hit that refrigerator and I'm all the way down to 30%, I'm looking at 11.75 volts. And at that point, it's probably not enough to start the truck. So I can get it jump started, but I'm going to have to do some battery work to get it where I can actually take off and have a reliable truck for my driver. So the other side of this is how much cycling is versus the depth to a discharge, excuse me. So the more cycle time I have, and especially the longer I'm discharging it, that actually takes away from the amount of time I can use that battery. And that's what our chart is showing here. So if I'm looking at my depth of discharge and I'm saying I'm going down to 20%, so I'm only dropping at that 80% level, kind of like we were with the starter and the lights. You'll see I can get a lot more number of cycles here than I can if I'm dropping it down to that 80% with those refrigerator down here towards the bottom. I'm barely going to get 1,000 cycles, probably about 500-600 is what I'm going to see there. So based off that cycle is also going to be based off of how long your batteries are going to last. So to recharge that, if I'm down to a completely discharged battery and I'm at 0 degrees, it'll take more than 100 hours, because at 0 degrees, that thing's only going to accept about 2 amps an hour. But one thing to remember about this too is at 0 degrees, if I have completely discharged that battery, I'm looking at water. Water freezes at 32 degrees. So I'm going to have to bring that inside a building or get that battery warm enough above 32 degrees so that electrolyte can melt and I can actually start the chemical process of recharging the battery. So that's the one thing we got to pay attention to is what are the temperatures around there and what's the temperature of my battery? So if I'm looking at flooded cell versus AGM, now I still have lead in there. I still use acid, and I'm creating voltage chemically that way. So a flooded cell battery has more free electrolyte. In other words, it's more of a liquid nature. Where an AGM or absorbent glass mat, that electrolyte's trapped in the mat, similar to a sponge. The advantage there is I have less leakage, if little to none, when I do have a cracked case or something going on in that battery. At the same time, you could see a charge comparison here where a flooded cell at 100% state of charge is only going to be about 12.65 volts, where an AGM is going to be 12.8 or more. Got a little more pressure there to push those electrons out to actually allow my load to work. Where yet when I get to that 50%, I'm at 12.2 on that AGM, so, or excuse me, on the flooded cell, where I'm 12.3 on the AGM. So I still have, that AGM still has an advantage there. Yet when I get to that 25% discharge rate and below, they're equal. The AGM and the flooded cell don't have a difference at all there. So let's look some at battery testing. Now, battery testing, once again, we're kind of using all our senses here because we're going to use our visual sense as we look at the case and at the post and the eyes. We're going to smell, because do I have that sulfur smell? Tells me that, am my battery overcharging? Is there a problem in that? We need to look at the state of charge. And at the same time, if I'm going to touch it, I'm going to do that in cleaning the cleanliness of the battery and some of those things. So determine the state of charge. This is without an open circuit, or excuse me, with an open circuit, no load on it. Then we're going to apply a load and determine what the actual capacity is in that battery. So the first thing we want to do is look at that battery case. In this case, we show you a picture of a cracked one. Dirty batteries, guys, even if that is dirty on top of that battery, we get a buildup of dust, dirt, and if it gets any electrolyte on it, it can create a discharge. So, if nothing else, take a couple minutes, take that rag, wipe those tops of the batteries off just to make sure that you're going to get some life out of them. You want to look at the studs, make sure there's nothing loose. Cables, what are the conditions of those? All those things are things we're going to look at. The hold downs, even is my battery being held in place, or is it running around loose? Those are things I have to know to make sure that I have a good battery. At the same time, some batteries still have this built-in hydrometer. Been around a long time. The one thing to note though, I'm looking at the ball and how is it floating within that electrolyte. So you see when you've got that very small, looks fully charged, that green ball is right in the middle. When I start to get low, needs to be recharged, and that's going to change it to a different shade. You see that ball's moved off to the other side. And then obviously if I see a clear one, I don't want to do anything with that battery, try to recharge it or anything, because my electrolyte level is low, and all I'm going to do is create gassing and possibly blow up that battery or create a problem. So at that point, we realize real quick, I want to move on, change it. Don't pass go. Don't collect $200. We're going to do what we got to do, but let's make that vehicle work right. So when we're looking at that battery post, you see the post on the left, that nut has been stripped out. That stud's stripped out. This is not a time to be a good mechanic and try to rethread it or anything like that. It is replaced. The one on the right, a little bit better, threads a little better, but it's a little closer to what we want to see. Is that stud's tied in there. In this case, I could see I had a decent electrical connection because I don't have any of the dirt and dust there on that lead pad, which is what the stud screws into. So the one thing we do want to do is, before we start testing, is we want to clean these things. And you'll see here in this picture, it is clean. This is an example of a good post ready to test. But my lead pad is that primary electrical connection. That's why it's always good for my cables to be making flat, good contact with that pad and not just touching that stud, because that stud is stainless steel, but it's only for stability to hold it, and it's only for the strength of that attachment. There is why we have that 3/8 stud. So if I'm doing this, and there's many different makes, models, brands, however you want to do it, but you need a good brush. You need to be able to clean that lead pad. At the same time, you need to be able, whenever you're testing, because a lot of techs are going to sit there and they're just going to put the leads straight to the stud. They need to realize that that stud could be loose, but either way, I'm not getting it on those lead pads, so I'm not going to have a true indication of the status or the state of that battery. The other one that's not on here is nothing more than a shop rag or a rag of some type. That way I can clean the top off, make sure it's clean before I start all my testing. So we're going to look at those battery cables. Also, and I'll get into that with some of the testers, but whenever I start separating, looking at my batteries, I need to look at the cables. Do I see corrosion? Is it white? Is it green? Are my cables bulged a little bit? Gives me a better indication of, do I have a problem with an electrical wire that's caused the problem with my batteries? So we want to try to make sure that the batteries truly are indeed the problem, or were they a secondary nature because I had a problem with the starting system or a voltage drop at my starter. Once again, put the lead battery studs on, the battery adapters. You can't, that's a step we can't afford to miss. To know exactly how my batteries are doing, I need those studs on there. Now, when it comes to test equipment, man, there's all kinds of different equipment available here. We see some of the old analog units here that have the dial on them. We could still use. We just have to make sure we understand how to use them. But I'm going to apply that load by twisting that knob in. At the same time, there's new electronic testers or electrical type testers. And that's the two you see on the right. Some of them have the built-in program. The one on the far right has a handheld or portable tablet that goes with it. Guys, these aren't the only brands. It's just happen to be the ones we sell, or have access to, excuse me, that we can sell to you. But that's why you see that brand. There's multiple brands. We're not trying to sell you on any one brand here. Just want to give you the types. So if I'm truly going to know the condition of my batteries, I do have to take the cables off. I do have to check them individually, because it's going to be very easy for me if I'm going to try and check multiple batteries together. They're going to test fine. It's when I separate them I can find out, is one better than the rest. Okay, so in this case, this one, when they're testing it, they actually have an amp clamp over that positive cable as well to see how many amps are actually coming out of it. We always want to measure or load these things at half of the cold cranking amps of the battery. So let's do another poll question here. So what is the proper and easiest way to find out if a battery has surface charge in it? Are we going to use the ye old test light? Are we going to do a load test? Are we going to use a voltmeter or multimeter? Or are we just going to take a metal strap and touch it from the positive to negative to see if we have a surface charge? What do you guys think here? Still got some time, guys. I see a lot of you guys answering questions here. Get a few more you answer here before we reveal answers to you. All right, let's look at it. So got a few of you guys are saying test light. Load test is another one. Guys, the correct way of telling if that thing has a surface charge is actually using a voltmeter. And I say that because if you've got a surface charge, you're going to be above 13 volts. And that's always a good indication that it's a little bit more there. We got to bring that down to that 12.8 to 13 before we turn around and do any type of testing on that battery. Make sure I didn't miss a slide here. All right. So to remove that surface charge, in this case, we're talking about a lead acid battery. That voltage is greater than 12.75 volts. So we need to remove that, and we're going to apply 300 amps for 15 seconds. We're going to allow that to set 15 to 30 minutes at a minimum, and then we're going to apply our load test. Now, if I'm using one of those pieces of electronic equipment, which is the newer testers we have, that's actually going to take that surface charge off automatically. I don't have to manually apply a load and take it back and do anything related to that. It takes the surface charge away, waits a few seconds, then it actually applies the load. So that's kind of the easiest thing. And the other side of that, what I always liked when I was in the field working on the batteries, is that electronic equipment, regardless of my tech's ability or experience, I could get very good results out of it. So if I'm doing the electronic equipment, and even if I'm not, I got to know what the CCA or the cold cranking amps of the battery is. And at the same time, we need to estimate the battery temperature. That battery temperature is not going to necessarily be what my outside temperature is. Good example of this is towards the winter time, and I've got 32 degrees outside. I bring the truck in. It's been sitting in the shop for an hour. Shop's about 70 degrees, 65 if I'm, if we're lucky. And so I type in 65 degrees when the actual temperature of that battery is only about 45 degrees. So I'm not really giving an accurate measurement of the state of my battery. So if nothing else, what I always want to do, shoot the battery with a little infrared thermometer. We have a lot of us have them in our toolboxes today. Shops have them. It's a quick check, and I know what that temperature is. Some of the newer testers actually give you a way to test it and record it. So need to know what the battery CCA is, need to have an idea what my temperature is, and then these testers, electronic testers, are going to automatically look at what the results should be based off that temperature. So let's look at this. So another poll question here. How long is a sufficient load to test my battery? So do I put my load on for 3 minutes, for 3 seconds, 15 seconds, or does it depend on the battery that's being tested? So let's get some ideas from the field here. See a lot of you guys answering. Keep them coming. Wait for a few more here. See where we're at. Okay. Let's see what that answer is. Definitely should be 15 seconds, okay? Whether I'm an AGM or a lead acid or flooded cell battery, it is 15 seconds. Purkeys does not have enough info at the moment to be able to tell you more about lithium, and they're still a little new to our field, so not all of that has been developed. So 15 seconds, if I'm doing a carbon pile tester, is the time that I need to put my load applied. So manual equipment, like we said, half the CCA, rated CCA, it's going to be applied for 15 seconds. So that means if I'm a 700 cold cranking amp battery, I'm going to apply 300 loads or 300 amps to it, excuse me. So dial that thing in till my gauge, my meter shows that 300 amps. And then a lot of these have, because we're only going to do it for 15 seconds, a lot of them have a little alarm or sound, a beep that shows afterwards. If not, you need to make sure you understand the 15 seconds. What is my battery voltage? Some of your testers have an analog meter. So we've got a little needle that moves around there. If I'm testing my batteries, I need to know exact voltages. So in that case, I'd want to have a multimeter connected to it and know that at the end of the 15 seconds that I have 10.56 volts or I have 12.2 volts, whatever the case may be, and 12.2 is way high. But I need to know more exact. And sometimes most of the time you don't see that with a analog type meter or needle type meter. So based off of that load, based off of the temperature, I could see that if I'm 70 degrees and above, after that 15 seconds, I should see a voltage greater than 9.6 volts, and that battery is good. As my temperature drops, so does my voltage. So about every 10 degrees, I'm going to see that drop about a tenth till I get down to that 30 to 40 degree range, and then I start dropping 0.2 at a time. Okay. Most of the time, if we're checking batteries, we're going to be doing it above 40 degrees, and our batteries are going to be there. By the way, if your vehicle's in the shop for about 4 hours, you can use that shop temperature. That seems to be the average that we use for any component on that truck to determine if it's at ambient temperature or not, or if it's still warm from sitting. And you may ask, why is that important? Well, the thing you need to know is that when I'm looking at my temperature, the colder the temperature, the more friction I have in that engine and those components, and I take an increased load on that. So if I'm looking at 32 degrees, I'm not getting the same load that I get at 100, 80 degrees. So at 80 degrees, it may take 600 amps to turn that engine over. When I get down to 30 degrees, now I'm looking at 165 amps. And so I'm looking over 200 to 300%, or excuse me, 165%. I'm looking at a huge increase, and I need to know that my batteries are going to handle that with cold cranking amps, as well as my little bit of my reserve capacity. As you see, you get down to zero. Now I only have 65% of my voltage in that battery available, but it's going to take 250% of that just to get that engine to turn over and start. That's usually why we see multiple battery applications on our vehicles and our equipment. So we can increase that cold cranking amps and still give that higher percentage to be able to start that truck. So at this point, we are going to field some questions that you guys may have. Love to say I've done a great job here, but I don't know if that's a true statement or not. One thing I could tell you, if you need more information, you can respond to that email that you got for the invite, and one of us will get back to you, try to give you the answers we need, be it related to batteries or with your electrical system, ways we can help you with that. Give you a few more minutes here. All right. Well, guys, we just want to thank you for taking the time to be with us today and out of your busy day. And hopefully you got some insight out of this that you can apply to your fleet. And at this point, we want to thank you. You guys have a great day.